Good morning, friends. Today we will cover chapter 17 using externalizable interface. Externalizable interface is actually a sub interface of the main serializable interface, but it has got additional methods like writeExternal and readExternal. So if we want to fully control Java serialization process and override JVM default serialization process, we can implement the externalizable interface and override its methods, writeExternal and readExternal. So once we use externalizable, the complete serialization and deserialization logic becomes our responsibility. Our means the developer's responsibility. In the previous chapters, we have seen that there are some ways that we were able to control a little bit of serialization. For example, using the transient keyword, we were able to blacklist some of the variables which we don't want to serialize or deserialize. For example, it can be primitive or it can be an object reference. Similarly, we also learned that using this writeObject and readObject methods, if we declare the same signature as here, we can again, using the default one, it will call the default JVM process. But we can also use the object output stream to write some of the fields, variables, values to the byte stream using this writeUTF or writeLong or writeInt, whatever the variable is. And similarly, we can override this readObject behavior as well, where we can read any of the variables that we have that we have not serialized back from the byte stream using object input stream, readUTF or readInt or readLong, whatever. Also, we saw that we can also, instead of blacklisting, we can also use whitelisting, which means that we can actually choose some of the fields from the Pojo class, some of the private field members, which we want to serialize or deserialize. And for that, we need to create, we need to just whitelist all those fields. For example, in this example, we are using 3 fields to be the part of Java serialization process. We marked it in the array of object stream field class, and then we just wrote our custom writeObject and readObject methods, where we actually put it into the object output stream put fields. And similarly, while retrieving it, we use object input stream get fields and retrieved all those whitelisted fields. But even in all these 3 ways, we have seen that there's always some part where we are actually relying on the JVM default serialization process. For example, in writeObject, we had this os.default writeObject method, and similarly in the readObject, we were using this is.default readObject. And so suppose if we want to completely take out the JVM process of serialization, we want everything to be done by the user, by the developer himself. For that, it was designed, we have to use externalizable interface, where the full control is given to the developer. The only thing we need to tell what to serialize using writeExternal method and what to deserialize using readExternal methods. And with implementation of writeExternal and readExternal methods, writeObject and readObject becomes redundant and do not get called. And using this externalizable interface and overriding this writeExternal and readExternal methods, we can even serialize static and transient variables. Although it's not a good practice. I mean, of course, it will be very confusing and the wrong way to do that. But what I'm trying to say is that it's possible to even include static and transient variables because the full control is with the developer. And when an externalizable object is reconstructed, reconstructed that when we deserialize it back, the object is created using public no-arg constructor before the readExternal method is called. In the serialization process, we learned that whenever we deserialize it back, the constructor is never called. This is what we also learned in our previous chapter on inheritance. But once we use externalizable, we have to provide a no-arg constructor. If we haven't provided any old-order constructor, then JVM will automatically include a default no-arg constructor. But if it's not there, then an exception is thrown, something as invalid class exception is thrown at runtime. So just taking as this example for externalizable, so we have to implement externalizable same way as we implement serializable, and then we see that there is also a transient and static field. But as mentioned that we have the developer has got full control, and we have to just override this writeExternal and readExternal methods, where we can write everything to this object output object using all those write UTF etc. Methods, and it also includes this transient and static variables as well. Similarly, in the readExternal method, using object input object class, we can read all these variables back, whatever we have written to the byte streams, including the transient and static fields. And we'll also learn that once we use writeObject and readObject methods, it's never being called, because writeExternal and readExternal will override it. It will not let writeObject and readObject methods being called. So we have covered enough of theory part. So let's dive into IntelliJ and write some test codes to understand this better.